Ladies and gentlemen, our distinguished presenter, Shri Nikhil Swami, is Head Academy, Frauscher Sensor Technology India Private Limited. He was earlier working as Project Director for Qatar branch of TCIL, a Government of India enterprise, and as Deputy General Manager Signaling for Kolkata Metro. Mr. Swami has published and presented technical papers in national and international events and at global forums. He is also the Vice Chairman of IRSE India section and actively involved in signaling related events, industry discourses, and activities in the region. Tags Frauscher, Nikhil Swami, Railways, hashtag innovation, etc. A very warm welcome to you, sir, and over to you for your presentation.
A very good day to all the attendees and participants. As has been introduced, I'm Nikhil Swami, and I'm presenting today on advanced train detection with innovative features and remote diagnostics for railway projects in India. This would be our broad agenda for today. We will look at Frauscher as a global group at a glance. We will look at the advanced digital counters which Frauscher is installing and supplying in India. We will have a quick overview of FADC, that is the Frauscher Advanced Counter, and how the track layout and indoor equipments are placed. We will look at setup and interfaces, the key capabilities, and we will come to diagnostic systems, which is also a core topic which I want to present today. So this is the Frauscher Global Group at a glance. We are pioneers of Excel counting in the world. We have installed sensors in 100 plus countries. And also we have an experience of more than 200,000 sensors or detection points across the world. So in terms of catering to different applications, we are able to provide a lot of flexibility. We are with main lines, urban and mass transit, and also industrial and mining operations. And the most important thing is that from last 30 years, we have a successful sensor development experience and also the installation and commissioning experience. This is a global product portfolio for Frauscher. So we have the wheel sensors, that is the detection devices at the track side, that is RSR 180, 123, 110. So today in this topic, I would be focusing on RSR 180. And also we have the platforms which processes the information, different boards. And as a whole, the platform is of two types, basically ACS 2000 and FADC, Frauscher Advanced Counter. And again, today we will be focusing upon the advanced counter, that is FADC. Apart from these two things, as a Excel counting system supplier, we have to interface with higher level systems. And that is where we provide the different standards, customer specific or Frauscher safe Ethernet. We will be talking about these software interfaces in this presentation today. These are the three products in terms of hardware and software that we are having in our portfolio. But apart from this, it's also about how we are giving the end customer services and customized solutions. So Frauscher provides a perfect integration in all railway segments. So it is main lines, urban and mass transit, and in industrial mining. If I talk about urban and mass transit, particularly as a secondary detection system for CBTC, in almost all the major Indian metro projects, Frauscher Excel counter is being supplied. Some of the projects and references, I'll be quick here. So we are working, if I talk about the region, in the length and the breadth of the country, and these are some key projects which I have mentioned. The areas where you don't see any projects are also having projects. So I've not mentioned everything in this slide, but these are some of the key projects, and we are working with all the zonal railways now, and also all key metro projects in India. Apart from the Indian operations, we are also covering, Southeast Asia projects in Indonesia, in Malaysia, Myanmar, Bangladesh, and even South Korea for that matter. So this was a quick introduction of what Frauscher does, and also setting the context of this presentation, and to establish that the topic that I've chosen about innovative features and remote diagnostics, we are doing a lot of work in that. So I wanted to share this particular information with you. So I'll come to axle counters now. So there are a lot of material that is available online where a person can compare. Anyone who is interested, what is better in terms of train detection technology, whether axle counters or track circuits. So I'm not going into too much detail of that, but I've just jotted down some of the key things which sets axle counters apart. The most important thing is that there is no dependence on ballast conditions in the case of axle counters, that is the sensors. The maintenance requirements are lower. It's established fact. There are a lot of reports and content that is available, which one can study if they are interested. There is overall, the life cycle costs are lower when we talk about axle counters, when we include everything and do a life cost analysis. And there is no practical limit on the track section length. So we know that track circuits, the alternative train detection technology, is having limited track section length, but with axle counters, we don't have that kind of a limitation. And one more point is that it is possible that we can have redundant train detection in axle counters. So now coming to the advanced train detection system. So I said Frauscher advanced counter. And the theme on which FADC has been built is more relevant information with lesser effort. And I will show you in the coming slides how this statement has been built and designed to reduce the effort which is required to gather the relevant information. Now, the real test of any component is when they are in real conditions and when they prove their metal for a long period of time in harsh environments. So as a wheel sensor, RSR 180, 123, 110 all have proven their metal in the harsh environment. These are some images from across the world, our projects in industrial mining and in cold conditions as well. So the sensor that you see in the image is IP68. And this is a key criteria for any outdoor device because it has to be robust. It is on a track bed and also it is clamped to the rail. So there is no drilling in the rail. And this gives this sensor the required strength and robustness to cater to the outdoor environment where the trains are moving fast over the sensor and it is able to work fine. In fact, I have not shared images for the, to ensure that we are able to complete in time. If I can tell you in Mumbai projects where there is Mumbai suburban, our sensors are working fine even in flooded conditions. So it shows that this is the key requirement when we talk about sensors and external devices. Moving forward, FADC, there are a number of case studies which we can share in the Indian project or internationally. It offers a number of advantages. Now, the key thing is that it is obviously vital and fail-safe as a system. It is quick and easy to install because outdoor installations and indoor installations are much easier. It operates in harsh environments, a point that I have already covered, and the low maintenance. So when we go for our customer services or trainings with the customer, and when we tell them these are the maintenance practices which are there for FADC system, we are surprised when we are told that this is so simple and so less. So this shows that we have put efforts in building the system in a way so that the end user is able to operate it in an easy manner. Now, this again is a design philosophy which India has to see and different projects have to see as we go forward, how we can simplify maintenance practices for the end customer and the end user. As I've already covered, it is easy to overlay. And in terms of compatibility, it is compatible with electric traction. There is no interferences issues as such, also overlaying on the track circuits, and no track alterations are needed. Quickly, the advantages which FADC is offering straight away to the customers is that there is no drilling. So this has also been established in different railway board letters that drilling impacts the track bed and also the rails. It weakens the rail. It also impacts in a way the driving comfort or the comfort of the passengers when they are moving in the train. So drilling as such is now not a recommended practice, and we are offering sensors which are clamped to the rail and there is no drilling required. Another key philosophy for axle counters, and I'm saying from the perspective of as we are going forward in future, in the next decade, would be reduce the trackside electronics. In fact, in our case, there is no trackside electronics, and all the electronics is available indoors in a protected environment compared to outdoors where there are chances of different transient surges, etc. So there is no trackside electronics in the case of Frauscher's sensors outdoor. The remote diagnostics capabilities I will cover in the last part of my presentation today, and I will exhibit how the remote diagnostics of future are being developed. There are flexible design capabilities. Another key feature is serial interface. So today in most of the projects, we are interfacing with the higher level system that is interlocking using relays. But this is not the future. We are now having experience of implementing numerous projects with serial interface. So the trend is already on in Western countries, but even in India, I would say now with a lot of experience in dedicated freight corridor projects and different projects where we have proposed and used serial interface. Now, to put it very simply, serial interface is avoiding the use of relays. You are straight away using our boards, which you can see on the left-hand side, and the ports here, which you can see. These ports you can use to directly interface with interlocking. So this is a game changer. And also we are in very close talks with proposing this solution for railways as well. And we see the day coming very soon where relays will be slowly replaced with all serial interfaces, giving the capability of sending advanced level of information apart from the regular information. There are other features, intelligent redundancy, intelligent functionality, some of which I will cover today. In terms of setup and interfaces, so this is the setup. That's it. This is the whole setup for FADC. It's as simple as that. At the outdoor, you can see there is a detection point. I've just used a very simple layout, detection points forming a track section, and there is a sensor cable. And also you can see at the outdoor, we have only these two things. I mean, the sensor and a junction box. That's it. And from the junction box, there are cables running in, and all this part is indoor. So from the BSI, everything is indoor. And we have the AEB board, that is the evaluation board, and then the COM board, and finally IXL. So the interlocking, we are doing the interface with the interlocking. As I said, serial interface or parallel interface, depending on the requirements. Going a further, little bit deeper into how we build our layout. So on the rail, we have the inductive wheel sensor and the junction box, as I was talking. And from the junction box, there are star quad cables or signaling cables which bring the information indoors. So indoor is where all our electronics is. And also, we don't need to do any adjustment in terms of electrical adjustments at the outdoor. And this gives a lot of advantages when you are installing the system. You want to simplify the installation, and also not during the operation stage, you don't want to do a lot of access related activities on the track side. So this is the overall layout. As I have explained before, with FADC and interlocking on the right hand side, there are multiple options of interfaces available, and Ethernet connectivity in a vital manner we are offering in terms of serial interface and also using different protocols. I'll touch upon the protocols also as we go ahead. So this is our outdoor equipment. I've just added some images to give you an overview. Again, the rail claw, we don't drill the rail, we are just clamping it. There is no separate earthing arrangement. There is no separate power or signaling cable. Just have one sensor cable, which is enough, having 4 wires inside to provide the power as well as also supply the information from the outside to the inside. And finally, we have the track lead junction box. If I talk about indoor, and I will not be going into detail of every board, but I'll just give you an idea that these are the 4 boards that build my entire system. So in terms of power supply board, communication board, advanced evaluation board, and input-output board. And all these 4 boards together build my system, building the advanced FADC Excel counting system, which is running successfully in India in a big way and also across the world. This is the log unit, FDS, and this is the standard BGTs, the board racks, where we place our boards. Now, moving forward, we have to be prepared for the future and the trend that has emerged in the last I would say, a decade or so, with a lot of successful installations in serial interface, is going digital. The relay has become outdated, and we have to be ready for digitalization. And we are ready for that because we have actually started with serial interface using the Ethernet ports that are available on the combo. This will allow you data processing, which is not available in the case of relays. It allows you data storage. A lot of capabilities come with data, we know that. And also it allows you cloud-based data management. So this is where we are going towards future, how to digitalize the data which we are acquiring from the field, from the system, and what all we can do with that data. Also, there is high demands on safety and availability. When we talk about data, we also have to focus on how we can ensure safe and available systems and use the diagnostic data for preventive maintenance. So these are the aspects as we go forward, we have to put more focus on in the industry. So to address all this, there is one particular thing which I would like to emphasize. There are many things which we are doing, but at this stage, I would say the Frauscher Safe Ethernet, it's a protocol, and it's allowing you free definition of file content. So it's an open source protocol which Frauscher has developed, and it's a fail-safe protocol, right? So in the software, you can use this protocol to transmit data up to 200 bytes in vital transmission cycles. And transmission is towards both sides. So just to make it simple for the elaborate audience, I would say FSE is a safe Ethernet protocol. It will allow you and it will provide you an easy software interface to interact with any safety critical system. So it is already developed, it's open source, and we collaborate with companies and we can transmit the data using the FSE from our system to another safety critical system or interlocking. So I've covered this point that it allows you 200 bytes of information, and it's redundant and network compatible point-to-point connection. So it's a safe Ethernet connection point-to-point, and it is built in redundant mode. So in terms of capabilities, there are a number of capabilities. I'm touching upon two of them in this presentation. So the architecture we can see is centralized, distributed, and mixed. So I'll just start with the right-hand side, the centralized architecture. So here you can see the depiction of hardware interface. So we have the sensors on the track side in a typical railway layout, maybe a yard or a station. And we can see from the sensor the same architecture, advanced evaluation board, and they're all internally connected in the indoor with the communication board. But here, interestingly, we also have one more board, that is IO board, input-output board, and this provides the potential field contacts to cater to railways requirement of relays, because through the relays, we will go to the interlocking. So this particular arrangement is the centralized architecture. We have one communication board here. Now, if we talk about the decentralized architecture, we can see there are multiple combos at different locations. So we can see this is one location, which can be seen in a light gray depiction, and this is another location. Okay, in the diagram they are shown very close, but assume a distance of maybe 8 to 10 kilometers or 5 kilometers in between. And these distributed locations can all be connected together in the network. That is how we are doing in different projects. And this allows us to build a modular, flexible architecture. So there is intelligence. With the help of COM board, we are able to connect the locations. So we don't have to really lay down a lot of cables from one place to the other and cover massive distances. So we have to utilize the technology and the development in the optical fibers to transmit the information. So this is just a glimpse of how flexible architecture is provided, and all this together can also be combined. That is why it is written as mixed. So this is on left side is distributed, and this one is a centralized depiction. So as I said, in terms of distances, there is no limitation. Why is that possible? Because we have used fiber, and practically there is no distance limitations. It operates and performs as a whole in a single system, right? And Ethernet connectivity, because COM board is through the Ethernet, it can be either through copper, fiber, mixed, or even the wireless. So we are doing some pilot projects where we can also, in future, that's also a future trend, where we will be doing all these transmissions through wireless mode. So another future trend emerging. Moving forward to the supervisor track sections, another flexible feature which I will cover here. And supervisor track sections are allowing automatic resetting of track sections in certain situations. So there are situations on the field when the track section is faulty and it's just a specific situation that has arisen. But without the supervisor track sections, it can affect the operation. So there is a feature that is provided to improve the availability of the system, is automatically resetting the track section without operator intervention. And this is being used across the world. The key point here is it automatically corrects false positives. Availability is increased, and safety-wise, it is SIL4 approved in a vital and fail-safe manner. We build supervisory track sections. Now, is that we have the track sections which are built on the track section 1, track section 2. But supervisory track section is built without using any additional hardware. So it is built in the software, and we use the virtual supervisory track section to build and to provide the availability. So there is a lot of details that we can share. Those of the in the audience who is interested to read these case studies, how we have presented these solutions, and they are, helping the end user. But at the moment, I would just say that there is a lot of configurational capabilities that we provide, and like supervisory track section, which we build using the software in the virtual mode without putting additional hardware. I mean, that is one way of doing it, but we are not putting any additional hardware and building the STS in the software. And reset can occur both in the top down. So top down would be from this to this, that is from supervisory track section to TS1 and TS2, and bottom up will be opposite of this. I'll come to the final part of my presentation now, the diagnostics and monitoring. So this is one aspect which we as a, I would say, region have to more focus now, because from the end user perspective, from the customer perspective, the diagnostic features are critically important, because these are the features which the user has to utilize when the operation is happening. So as a supplier, this is a far call that we have taken in building an FDS system, because we are thinking about the end user. And this is the layout that we provide. So this is not the interlocking VDU, my FDS, Frauscher Diagnostic System, which we provide for every project. So every project will have its own typical layout. Now, what is fancy about this layout? The main thing is that all these objects and entities that you see on the layout, whether it is detection point, track section, all these entities, you can use the mouse and the click option, and you can click on them to read their statuses. That is point number 1. So you can see, let's say it has been clicked as detection point 12. If it is blurred, I apologize for that. But DP12, yes, so it has been clicked, and you can see different information. I'm not going into detail of this, but statuses, sensor currents, adjustments, traversal, speed, direction, all this information sitting inside your, I would say, signal equipment room or maintenance terminal or a centralized location. You are able to access information for the whole layout. And this is, as I said, the future, because as operators, if I say from the perspective of operators, we have to look for systems which are providing such level of diagnostics in their offer. Let me give you a little bit more glimpse of FDS. So it is advanced diagnostics. It's not the standard diagnostics. It takes it one level further, and it provides you the track layout, the logging, and the diagnostic features, and it reduces maintenance cost. You don't have to send a person all the time to the field to check the sensor. You can do a lot of diagnostics only while sitting inside your indoors. So we can see there are two particular information. So in this case, it is the detection point, that is the DP. All this information is available. It is the speed, as I said, status logged, visualized in track layout, sensor adjustment, when was the sensor adjusted, last traversals, the status of counting head control, a feature which are not covered here, sensor currents, and detection point condition. So you can foresee whether the detection point is okay, what is the status, you can understand it. On the track section side, so from the railways point of view, this is more critical in terms of what is the status of track section as a whole, whether it is waiting for a clearing of track, it is in reset mode, the number of axle counters, the status, whether it is online, offline, all these things about the track section also you can track. So what I want to say here is that we have to choose diagnostic systems which are comprehensive and they go into an advanced level of information exchange. And again, all this is happening using the communication board and the Ethernet ports we are connecting in the network. Also, anywhere in the network, you can get this information. Now, before I go towards the conclusion of my slide, I would also introduce here the remote monitoring display. Again, something which we talk about the future in terms of diagnostics. So this RMD is again a game-changing moment for us because it is giving us a remote monitoring display in a very comprehensive manner. So it combines multiple Frauscher diagnostic systems at different locations, and at a centralized location, it is giving you a much advanced level of diagnostic system. So it will do the analysis, it will generate the reports, it will give you regular emails. And not only that, it will go into an analytical point of view to assess the system health, the components health, warnings, and the errors. So there is a lot of things which you can do using the errors, warnings, and resets using the RMD. Again, as I was saying, that it can analyze things just for the idea, like wheel sensor current in the last 30 days, it is analyzing how it is varying. It is giving you an alarm history, statistics, code racks. Now, again, from the perspective of end user, this is how you utilize data. So this is, we are living in a digital world where data is, most important thing, and all the data processing part is going with the RMD using the capabilities of advanced diagnostics. We can see there are application areas are reporting and alarming, which is very important from the end user, and also the maintenance effort overall is reduced from the individual point of view, but in terms of capabilities, the effort, maintenance related effort is increased, and quick access to information. In terms of layout, I have just covered this image before I conclude how the RMD is established. So as I said, at the track level, the sensors. At the second level, we have the indoor equipments. This was my board racks and the cubicles at different indoor location, let's say station 1, station 2, auto huts or RH. And at the FDS level, in the network, we are building the network. And finally, there is a remote monitoring display, which is our offering now. And we are implementing pilot projects in certain projects in India as well for the RMD, where we are collecting vital data and exhibiting our skills. So this is it. From my side, I would like to thank Real Analysis for giving me an opportunity to share the advancements in Excel counters and how we can provide solutions to the Indian market and the region. Thank you so much.